later for that, but it's fine.
Wait, what?
Wait, no, 5 minutes.
Yeah, I know.
Wait, no. Then, yeah, Kira just kept everything.
Well, you guys have so many snacks.
We rated job too.
Why?
What?
Why though?
Because we love food.
Door. Door. Okay.
Audio check, audio check, audio check, audio check, audio check. Alright, back to some folks. Oh, that's what that sound is. The mic so people can hear that conversation.
It's too late. It's too late. It's been had.
Tell me about how
I didn't
synthesizers are
hear.
non-GMO.
Synthesizers are horrible. They are not instruments. Synthesizers are GMOs. They are non-free range.
I don't understand how a synthesizer can be free range.
What is a
Because it's
synthesizer?
thing.
Are you talking about like music stuff?
Are we talking about like letting the synthesizers roam the prairies and just like giant like piano
Organic
rolls?
instruments that are played from the heart are free range.
No one has a heart. What are you talking about?
What is an organic instrument? They're all made of like metal and wood.
But like it's
What is
the sound-
organic?
The sound is organic.
What is
The
organic?
sound is organic. It's played.
Would you buy these instruments at Trader Joe's? Okay. All right, let's start. Enough memeing, enough laughing. All right. Hey everyone. So today we're going to be covering. If you were here for the last week's workshop, it was very say dry, to put it nicely. This week we're going to be covering stuff that's a little bit more useful immediately, especially seeing as most of the games in this club are in 2D. Delicious, delicious coffee. And we shouldn't be going that long this time. However, before we get to start, last week there was a thing I wanted to do where, yeah, there we go. There was a thing I wanted to do which I couldn't get to do, which was essentially modifying vertex information based on a texture. And I got that to work. So enjoy this horrific image of whatever it is. So yeah, that's all done via shaders. Big thumbs up. Would any of you like me to explain that very quickly how this works?
How does it work?
Thank you, Oscar. You're saving my life. Only one that cares. Not that everyone else doesn't. So the way it works is that I have a main texture here, which is using Perlin noise. Let me select that. Come on, show me it. And I'm gonna explain more about Perlin noise in the future. The future being in like 20 minutes. It's essentially, do you know what noise is? It's kind of like random numbers used to kind of introduce some kind of randomness within your shader program usually. But the way that Perlin noise works is if you look at it and it's like, it kind of looks blurry, that's on purpose. Perlin noise exists as a smooth gradienting noise, so you get like a really naturalistic looking look because everything is just kind of, I guess, interpolating between like values cleanly. You're not getting any real jutteriness, it's just all kind of like going back and forth from 0 to 1. The origin of Perlin noise is kind of funny. It was created for the movie Tron because a mathematician was told, hey, you need to make these computers look natural, at which point he's like, that's nonsense, and he made Perlin noise. And then 10 years down the road, he's like, man, Perlin noise sucks. I'm gonna make a better noise algorithm. And he did, and it's called Simplex. However, Perlin noise for most games is the standard, and it's what we use. I'll be showing you effects later on that once you see them in here, it's going to be really hilarious because I see Perlin noise used all the time in video games now. Much to my frustration because it's like, my illusion, my suspension of disbelief, you're just using a Perlin noise texture, blah, blah, blah. But yeah, so what I'm doing, if I'll pull this up, is I'm saying like, hey, here's a main texture, and then in my vertex function, I'm saying like, hey, v.vertex plus equal some float 4, and I'm taking the normals of the object, that's a topic we're probably going to have to cover next week, and multiplying it by the Perlin noise texture amount. So here's a fun thing about vertex function texture lookups is that, so in video games you don't always want to have your texture loaded at its max resolution. Like if something is way off in the distance, like that's barely visible, even like with the shitty TV, that's barely visible. So more often than not, what they'll do is they'll say like, hey, texture 2D, this texture 2D, hold on. Text, caps lock, why? Text 2D. This function, which is how we get our textures, will in the background essentially automatically pick a level of detail for us. Meaning that as a texture gets farther and farther away, it will decrease the resolution on it. However, we need that information, we get that distance information from the vertex shader, so we can't use this in there and instead have to do this, which is a essentially manual way of doing it, where it's just like, hey, give me a texture and give me this texture, and then here's a float 4 that says where on the screen it should be and how much detail it should have, like what level of detail. So I could do like level like 64, and so fun thing is that that's actually like 0 detail. If I do the same thing down here, you'll notice it's just a square, or not even a square, it's just a single color because the level of detail is so low. Maximum level of detail is 0. I think the minimum is 4. So like if I go to like 4, should be, yeah, notice that that's really not great. It's pretty juddery. But that's because it's choosing a lower level of detail for the texture lookup. So that's something I did last time that I was really excited to do. What happens if I do 4 here? I have a feeling that that's...
7 was 4, the first one was 1.
That's fun, little PS1-like effects. Also, fun fact, this little 0 right here, based on the stuff I looked up online, which is the NVIDIA CG toolbook, that 0 does nothing. They're literally like, you want your X and Y for your UVs, and then your W for your level of detail, and it's just like, okay, what about Z? Okay, fine, there is no Z. Why do you have a Z then? But yeah.
Why did you change it? Like literally not have it?
Well, like I can set this to like 100 and we can see. Yeah, nothing really changed. Yeah. And you know, we can set this to like negative and check. Yeah, nothing.
Amazing.
Yeah, Z is it's just not used. It's really weird. But yeah, so that was something that I was trying to do at the very tail end of last week. So moving on to this week's topic, sprites. So you might recognize this sprite. This is the scaffold player sprite. And essentially, if we go into wireframe view for sprites, what is that? Like, can anyone tell me explicitly what that is?
2 triangles. Yep.
Conan, raise your hand. But thank you, yes. It is essentially just 2 triangles. It's a cube, and we're slapping a texture on top of the cube. So because it's actually triangles and it actually does exist in a 3D space, sprite shaders look very, very, very similar to a normal shader. I'm going to go through this whole block is the major difference, essentially, which is where the Unity's tag system and all of these extra little preprocessors come into play. But if we go through the rest of it, it kind of just looks like a normal shader. So let's go back to shaded. Cool. So let's just take a look at some of these weirdos, like these and the tags. So Unity has a tag system for its rendering, essentially telling the renderer how it should treat this object when it's going through the rendering process. The ones I know explicitly are Q equal transparent and render type equal transparent. Ignore projector, preview type, and can use sprite atlas are actually things that are a little bit beyond me in terms of knowledge. Unity, this is actually directly from, hold on, let me open up a Google Chrome. Unity actually has this code, Unity Sprite Shader, directly on their GitHub account. So it's very, very, very similar with a small little things difference. But yeah, so for the most part, it's kind of the same thing. Q is essentially when to render, like I said here. If we pop open the, gosh, it's hard to read this. Analysis, right? Frame debugger, here we go. If we pop open the frame debugger, which lets us, this is a really good tool, by the way. It lets you see step by step by step when things are getting drawn. So as you can see here, it says render.transparent geometry. So because we said, hey, render type or render Q is equal to transparent, we render there. We can change this to opaque. And that should change the render queue. Yeah, see now it's in forward render opaque, render loop, draw dynamic. So we're essentially saying like, hey, you know, render it transparently. Can anyone tell me why we render it transparent? Like why we default to transparencies for sprites? Yeah, Conan.
Because not all the pixels are like fully opaque. There are some transparencies for the sides.
Yep, exactly. The entire sprite is not opaque. There is essentially transparencies everywhere. Like, if we actually were to say like, hey, just set this whole thing to one color. Come on, like, look at all of this space that's like actually not colored. That's technically still part of the sprite. So we have to say like, we have to put it on a transparent level because that means that anything drawn behind it will show up in the transparencies. If we said, hey, how do I put this? If we said that it was opaque and then rendered the transparencies, what would end up happening is anything behind this object would disappear because we're rendering on top of something else. And we can only see what's behind something else if we render it afterwards. It's a little bit complicated, but it's pretty self-explanatory once you look at the render jobs and how they handle it step by step by step. So the rest of this is a pretty normal thing. Render type transparent. This is probably for some back-end stuff for Unity as well. Can use sprite atlas. So this is probably a feature that this is a feature I've never used, although I hear a lot of people say like we really, really should use this more often. Usually in AAA games, is that essentially instead of having one sprite for one thing, what they'll do is they'll create a sprite atlas, which is a giant sprite sheet of a bunch of different sprites. They'll zoom into the sprite sheet at a certain point, and they'll move where they're looking at in order to get different sprites. This means that you can kind of batch more things because you don't have to load a new texture in every time, and it's a performance boost. However, we are never ever really going to run into that performance issue. As far as I'm concerned, no one here is going to build enough sprites to use in a game that would require sprite atlasing. So I would say you don't really necessarily need to worry about this right now. However, if for some reason you're like, man, there's like 500 different sprites I'm rendering on screen right now, that could probably save your life in terms of performance. So the rest of this. Z-Right. So Z-Right is the depth. Essentially, like, how far do we want to treat the depth? And the thing about that is, with sprites, there is no depth. You know, they're just kind of billboards sitting in 3D space, pretending to be in 2D. But it's essentially, you know, there's no depth. So why would we have any depth right? Why would we care about the depth of this sprite when obviously it has no depth? Cull. So a thing that Unity does is backface culling. Essentially, if you have a plane, let me pull up a plane right now. 3D object, plane. If you have a plane in a Unity scene, we only see the front side of the plane, the side that the normal is hitting us. If we turn around, it completely disappears. However, you maybe don't really want that for a sprite, so if I comment this out, the sprite completely disappears from the backside. I've actually ran into an issue where I was writing a shader for a 2D game, and I didn't know about that. And the designer, I want to say, put the sprite in backwards. So they were like, why isn't the sprite showing up? Like, it's showing up in editor, but it's not showing up in game. And I was going in, and I was like, what's going on? It shouldn't be culling it. But I had forgotten to put cull off. So it got removed. So yeah, cull off. Now it doesn't matter what side we're on, we're always going to see it. Blend. So this is for blending the background color and the foreground color. So blending is one of those things I really dislike. Unity blend modes. I find that Unity blending, if you've ever used Photoshop before and used the blending, like look at all these different blends, and look at all these different blend factors. If you've ever used blending in a Photoshop or image editor before, this might be okay for you. I personally find it more often than not incredibly frustrating to understand. So like, hey, you know, alpha testing and cutout, and then alpha to coverage, and all these different kind of blends. So the one that the sprite renderer uses is blend 1 and 1 minus SRC alpha. If you ask me what that is, 1 is the value of 1. The value of 1 is 1. Use this to let either the source or the destination color come through fully. So that's essentially saying like, hey, everything, oh, I'm flipping so fast. This is essentially saying everything behind the sprite is 1. It's rendered to 1. It is the full color set. It is everything. And 1 minus SRC alpha is how we're treating the sprite. And that is the value of the stage is multiplied by 1 minus the source color. So that's essentially going to put us in, it's going to put us in -1 space for alpha, which will get clipped, meaning it'll get removed from rendering. Lighting off. I actually tried to Google this earlier and what this keyword does for shaders, and I couldn't find it very quickly. My assumption is that it does exactly as it implies. It turns the lighting off. Giant shrug, you know. Some of you might want lighting with your sprites, and we can go over that in a later shader talk. However, I'm not going to go over that today, sadly. I'm afraid of normal maps, and I don't like using them, so I'm not going to use them here if I can't explain them. And again, pass. And everything past this looks very familiar. The one difference in the vertex function is Unity pixel snap. So this is kind of a thing that's very particular. And I actually cannot see it by myself. But like, essentially the idea is that, you know, if we're doing pixel art, we want it to snap to a pixel. We don't want the pixel art to get caught in between pixels and have weird interpolation issues. So what this does is this essentially says like, hey, snap the pixel on the piece of art to the nearest pixel on the screen. It keeps things from going in between pixels, getting resized weirdly, and kind of maintains your aesthetic. Personally, when I bumped up the size on the sprite to try and see that, I didn't really catch it all that often. I feel like it just doesn't really have an effect with a sprite this large. But hey, that's... you know, this should probably be in there. Like, if you're doing sprite work, you should probably put that in there just to make sure that everything's okay. And then the final thing is the fragment. We're multiplying the color by the alpha. So disregard this comment. Let me just, you know, can anyone tell me why you would do that? No?
You want it to get
Yeah, so if we essentially set an RGB value to 0 here, because of 1 minus source alpha, we're saying like, hey, we're going below 0, so kill that pixel. And that's essentially the default sprite renderer. It's really not that bad. Like, this is literally what you use every time you're using a sprite. Oh, one thing I forgot to mention. Because of the way that Unity likes... Is that locked? That's locked. Because of the way that Unity likes you to use sprites via the sprite renderer, more often than not, you'll be passing the sprite through here and not through a shader property. What you do for that is say per renderer data. This essentially is telling the shader that, hey, the input for this is not going to be coming from the editor. It's going to be coming from some kind of script or something else in a different component. It just makes it your life a little bit easier. And I think, I want to say that it has rendering things as well, where it's just like, it's not going to bake or it's not going to try and batch these renders together if it knows it can't because of the per renderer data, because it now needs to be dependent on some other data somewhere else. So it's just not going to pull that. And tint, you know, always nice to have a color tint. It's all red. So yeah, that's pretty much the standard shader, but you know, there's so much more we can do with this. Let's write something fun. Let's write something that totally isn't here already. Let's pretend that it's not here. Let's pretend I didn't write it down earlier, you know, how that goes. And let's do a palette shader. So for those of you who don't know what a palette is, Street Fighter, Third Strike, palettes. Let's go with Third Strike's my favorite Sprite game. So in old fighting games specifically, what they'd do is they'd have a lot of different versions of colors for each character. Now the thing is that memory was limited on those machines. So the way they would do them is they would essentially create what's called a lookup texture. So I wish that they had included a lookup texture for some of these colors. Let's see, Third Strike. What, maybe? LUT stands for lookup texture. All right, I'm not seeing anything. So essentially what they do is they take, gosh, this is gonna be so small. I wish I could, full screen, come on! All right, it's not gonna get any bigger than that. Essentially what this is a gradient texture. Here, let's use our handy dandy tool that my good friend Greg made. Greg made a nice tool for our capstone that essentially lets you generate LUTs from within Unity. It's super awesome and nice. And essentially a LUT, what it is it's essentially like, hey, at this pixel, we are this color. Which means that we can say like, hey, you know, I want a red, and you know, let's say from value X to B, we want it to be black, and from value Z to D, we want it to, why am I saying these weird ass numbers for this? Yeah, like that's our lookup table. And let's save it under tutorials to export LUT. LUT is called tutorial. Yeah. And yeah, that should be somewhere there. Or I mistyped something somewhere. Hold on, give me 1 sec. There it is. Let's delete that folder. It doesn't need to exist anymore. So yeah, now we have this tutorial LUT, and you're gonna want to set it to sprite, point, no compression. Does everyone know what the import settings here are for? I'm just gonna go over them really quickly. So with sprites, you particularly, we check down on my player sprite. Here's the imports. You always want to set your texture type to sprite for sprites. It's just going to mean that, like, hey, you're not going to be rendering anything unnecessarily. And I noticed some weird artifacting when I was trying to use a sprite, but I wasn't importing it as a sprite. And typically you want to have it set to filter mode point. What this means is that it's not going to try and essentially apply some kind of blur or filter to it in order to like make it more, how do I put this? More performant for 3D. Generally, if you're doing a 3D game, you do want to use bilinear or even trilinear filter modes. However, for sprites, because we want them to be sharp and crisp, you should always use point, as this will get you 1-to-1. And the wrap mode, so I generally put my wrap mode on repeat, but it actually doesn't really matter unless you're moving the UVs, which we'll see later probably. Essentially, that's like, if I do clamp and then say tiled. Funny. Would have thought that just stretched out whack-like. We'll see this a little bit later, but it's essentially the way that Unity is going to handle it if your sprite goes out of the sprite renderer or your sprite is too small for the sprite renderer. Oh, there's actually a good way for me to show this off right now. Let's go and turn off the blending. Just turn that off. Huh, that's actually not as bad as I thought it would be. Let's turn off the blending. There we go. Yeah, there. Finally got it to work the way I wanted it to. So this is essentially saying like, hey, we're clamping it. So the colors are gonna go all the way to the edge. They're not going to essentially stop. They're just gonna go all the way to the edge as we go out. This is a thing that Unity does. If I go to repeat and apply, it's probably gonna be not different at all. That's strange, but okay. And that's gonna matter more as we do more weird UV map stuff today. But yeah, so let's go back to our LUT stuff. So, hey, cool, we have this really, really, really tiny, I'm sorry, it's so tiny, but it's literally 1 pixel tall. So what do you expect? We have this really, really tiny LUT, which we can then use as a lookup texture in order to change the colors on our sprite. And there's kind of an easy way to do this. So let's copy paste this. Where is it? Standard shader. And let's call it the LUT example. Example. Spelled that wrong, but who cares? Not me. Blah, blah, blah. Who cares? Not me. And let's say we want it as a texture. So lookup. Texture for lookups. 2D is equal to white, because why not? Not really sure if I could set that to any other color. I've never really tried. And that should give us, let's first switch this over, tutorial to defasted. Cool. So there we have our lookup texture, and nothing happened. Well, it's because we haven't really done anything yet, but let's continue. So fun thing about lookup textures is actually we don't need to do much to get it to work. Essentially, all we need to do is say, hey, I want a new color, new fixed for, lookup is equal to text to D on, and I forgot I need to make sure that this is here, underscore, what did I call it, lookup? There we go. ST, cool. And then we want to say underscore lookup col.r. Hold on. Formatting, please float to col.r 0. And let's see if that works. I have a feeling it's gonna freak out and or not. Undefined opaque. What? Did I not change that? What do you mean undefined opaque? Clear that out. Doesn't matter. Oh, I didn't return the lookup right. Dummy me.
How'd you create that file?
Ah. Yeah. Hold on. Give me 1 second. Lookup .rgb tons equal col.a. This will mask it and should clear out the back. And then for some reason we still got that back color being black, and I'm not sure why that is. Maybe I have to do lookup.a? Alright, cool. Hold on. The illusion falls. I actually already did this shader. Make sure I did this right. But I do that! Alright. A. This keyboard is nice and simultaneously wild. There we go, cool. So what we've done is we've essentially said like, hey, the red values in our sprite are now our indexes into the sprite. So let's look at this code again. And the magic line is kind of this line right here. So can anyone tell me exactly what I'm doing here? Like what exactly is going on with this? Yes, Dick.
You're setting lookup to be the color inside of the underscore lookup texture at position pol.r, 0.
Exactly. That's like literally exactly what it is. So because our value is like, because of our value on the y is essentially 1 pixel long, I just say 0 because hey, it's the first index. And then we're saying color.r, so that returns us a value from 0 to 255 because hey, colors are 0 to 255. And because our lookup table is, hold on, which one is it? This one's 32, this one's 256, so that's the correct one because there's no 0 pixel. Because our lookup table is 255 in nature, we essentially say like, hey, for every single individual pixel on the x, whatever value is at r on the actual texture, change it with this one. So we can do this with a lot, and this actually is really, really versatile for creating real fast new sprites. Like, hey, look, new style, new style. And we can just kind of hot swap these all we want. So this is what fighting games would do because, hey, look, our, hold on a second, the import settings on this are wrong. This should be a sprite. And you'll know it's wrong because look, there's like this weird 1 pixel yellow line right here. So we'll set that to sprite, turn off the compression, and that's a little bit better. Hold on, point clamp. All right, I guess that's okay. Maybe my eyes are just playing tricks on me because this TV's bad. But yeah, so I used this for a game to essentially create 25 different variations for zombies with 5 sprites. I had 5 zombie sprites, 5 shaders, or 5 lookup tables, and I had 5 damage zombie sprites. And essentially it meant that we could have 75 different possible zombies at one time because, hey, 5 different normal zombies plus 5 different sprites gives us 25 different possible zombies to begin with. And then plus the damaged colors, plus the amount of zombies from that, plus essentially it gives you a really, really fast way to just say like, hey, I need a different color of this thing really quickly. And making lookup tables is actually really, oh sick, we have Krita. Making lookup tables outside of Unity is also really, really easy. If Krita will load, oh, it's an old version of Krita. Essentially, we just need to say like, hey, how many pixels is this? 32 pixels by 1, 16 pixels by 1, 45 pixels by 1. Don't use 45, that's a weird number. Try to make it a multiple of 2 most likely. But yeah, essentially it means that we can very, very quickly, that's the OBS, don't look at that. Control new. Let's do a 2 by 1. So we're gonna get like literally 2 different colors in here. Gosh, I'm gonna have to find a pen that's a pixel pen. Pixel art, thank you. It's too large, hold on. 1, sprite, and then let's make this white. And then let's export that to, where's it gonna be, where's it gonna be, where's it gonna be, where's it gonna be, B. That's not the right workshops. Well, either way, what?
So does that mean the original sprite's just going to be like black and red?
Yeah, so if you want to do this really well and get a nice, good palette, essentially you need to hard limit yourself in terms of color. Because you can only have 255 possible colors. Sorry, 256. You shouldn't hit that. Like, color theory suggests you probably shouldn't be using that many colors to begin with. And one of the problems with this default sprite, sorry, I'm gonna put Henry on blast, is that they didn't really stick to a very like particular color palette. They actually didn't really follow pixel art standards. They kind of just said like, hey, whatever color would work best here. which isn't really how pixel art works. Pixel art works when you're very, very limited on choices and very, very particular about your choices. Color reuse for apparently no reason. There's a reason Mega Man is all blue, and it's because the NES had a ton of shades of blue. Pixel art is a lot of choices made out of necessity. And shaders, sorry, blah, blah. Doing a palette shader like this is essentially you have to make sure that your art is art of necessity. That you said, hey, we only have this many values. So when you're making a good palette shaded object, you really are going to be looking at gray for the most of the time. It's literally just going to be like, hey, this is gray 255, that's gray 128, this is black, so it's 0. But that's the way you get really precise and nice looking palette swap shaders. So, you know, we've done this. That's cool. That's really helpful. That'll make our lives easier theoretically in the future if we wanted to make a game with a ton of different colors in it that we could just hot swap out. A good example of this is Downwell. Has anyone played Downwell here? Downwell is really nice. Also, Downwell palettes. Downwell essentially has a post-processing that changes the entire palette of the game. So essentially, they were able to create all these distinct looks by simply maybe doing a post-processing effect, choosing a different set of 16 colors, and just going wild. Like, look, those are all the same game, but they look pretty different because of the palettes. Like, look, that's a GBA palette. Like, that looks great. So let's close Krita. We don't need it right now, and we probably won't for the rest of my time here. So, cool. That is a really good sprite shader. But say, you know, you go to your artist and you're like, damn, you know what I need? A pulsing colored outline. At which point you should have told your artist that to begin with. However, if you're really late into production, it's not like you're lost. You can make a sprite outline via shape. There are multiple ways to do this. I, for one, always thought there was one way to do this, and when I started looking it up to study for doing this workshop, I found that there's actually a way better way to do this. But I'm going to show you both ways just because I think it's worth seeing. So let's copy paste our just standard sprite and call this one outline example. Example. My caps lock is on, so that was completely out of whack. Example. And let's change this to outline dumb. Cool. So how can someone give me an example of a good way to do this? Like right off the top of the head. Because there's two ways to do this, and I'm going to change the name of outline dumb depending on which one you recommend. Because there is a smart way to do this, and then there's the way I always thought was the actual way to do this. Yeah.
Expanding the vertices.
That's the way I thought was, I'm going to do that right now, and that is the way I was taught, and there's another good way as well. Were you raising it?
I don't know. Sample a bigger area around the place, and then if any of them has like a color in it, then you set it to like something to be so it's outlined.
Okay, that's a third way. I didn't think of that, is sampling the surrounding pixels for essentially some color, and if there is no color, you change it?
Yeah.
I actually think that Google Chrome, I want to say Shaders Lab did this. That's probably makeup and not actually shaders, because I'm seeing Shaders Lab. That's a 3. Project without all shaders. Is that a 3 or am I blind? Okay, okay, cool. Outline and screen space texture. Oh no, that's not the right outline. There's multiple outlines here. If I can spell outline correct. Outline for sprite. So yeah, that's actually, this is the way that you suggested doing it, which is, oh no, never mind. That changed. He did this in a different way. I thought he used to. Okay, well I'm dumb. This is the better way that I learned about recently. I think I remember seeing this tutorial a long time ago, and the way he used to do it was he would take every single pixel and essentially run a for loop around all 9 surrounding pixels to check if they were in alpha or not. Which you can do that in shaders, and as long as you're limiting your for loops to a very specific amount, it'll be okay, air quotes okay, but this is the right way now to do it. But I'm going to show you both because I think it's fun to show both. And it's fun to see everything. So let's change to our new one, tutorial 2, outline dumb, and let's not call it outline dumb because that's dismissive of a lot of stuff. Capital outline. So we're gonna just repurpose the tint color here, and let's also add a size variable. Size, no, so as size. Sorry, I'm gonna 0, 1 is equal to 0. Just set it at that. And then let's do the 2-pass way, which is the growing the vert way. So first things first is let's grow the verts. So let's say vertex times, what just happened? Vertex times underscore size. I need to declare size, so float underscore size. Cool. So size is 0. Whoa! Getting bigger. Let's bump up that range to be even larger. So let's say 2. So now we should be able to go beyond. They're beyond. So yeah, now we're sitting at like 2 times. And if we were to say, hey, you know, we just want the outline here. Actually, it's interesting to me that it's letting me go so far beyond. That's interesting. I would have thought it would have stopped me. Whatever, cool. No skin off my bones. Let's just set it to the tint. Like, let's just say like color is equal to underscore tint. So I don't have to make a new variable. And then, actually we still need to do that. Hold on. Underscore tint.rgb is equal to underscore tint.rgb. Because we need to still mask it. That should not work. Because I didn't return tint. There we go. Kind of. Let's say tint.a is equal to col.a. Tint.a is equal to col.a. There we go. So now we have just the silhouette. And if you look at an outline, what you're actually looking at majorly is just an expanded silhouette that's set to a particular color. So now is the part that I'm not the hugest fan of, and this is why I kind of told everyone for a very, very, very long time, hey, if you need an outline on your sprite, literally just like duplicate it, make a second sprite, size it up, change the color, and put it behind. If it would let me. Oh, wait, hold on. Yeah, like literally just make a new sprite. That was what my advice was forever. Or ask your artists very specifically, hey, I need an outline on this. Can you give me a scaled up silhouette version of this? However, the reason why I was doing that is because of the way I thought was the only way to really do this. It's a lot of copy pasta. Hold on. Can I do I have to do that? Yeah, I have to do that. Ugh. Second pass. Yeah, so it used to be that the way I would do this is via a second pass, which essentially meant that like color times equal tint, and then I almost said RPG, col.rgb, cool. So, oof, that's very red. Let's not tint for now. So yeah, now we have it as a big old outline, and let's bring it down a little bit. Let's make it maybe like Super Saiyan Gold or Super Saiyan Blue. Let's go blue, yeah. So like, there we go. We have an outline, but there's kind of a lot of problems with this. Like, I don't know, it's just, you know, it's kind of off. Like, we're kind of missing some weird outline places. It kind of goes beyond and above where you would want. Sometimes it's just getting clipped entirely. We don't really have that much control over it, and it's kind of weird, in all honesty. It's just, also, it's 2 passes. So if we go to our frame debugger and check, we now are having like 2 draw calls, one for the silhouette and one for the sprite. Now, for most games, this isn't really necessarily going to be that bad of a performance issue. However, I'm a performance nut, and this bothers the heck out of me. So let's do a better way. Let's do a smarter way. Let's, for one thing, stop doing copy pastas because, oof, gross, no. What we want to do is we want to instead make multiple versions of it at different UV layouts and then add all of the resulting together. So instead of doing that, let's do float. And I apologize, I actually only saw this answer like 2 days ago. So if there's a shit ton of compile errors in Magenta, I'm sorry. I.uv plus, or I.uv.x plus underscore size, I.uv.y. Okay, that should work. And then copy pastaing. Oh god, all those tabs. Okay, cool. And let's call this, if we're adding to the size, then let's say that's probably going to be add on x. So that's going to be call x. And actually, we probably need to do add on size xy. Let's just plus. Where's the plus on this keyboard? Ugh. Plus. And what are the 4 situations we're going to need here? Anyone want to take a quick hazard at what we're going to have to do here? Oscar, you're making finger directions. However, I'd appreciate a voice.
Are you gonna make like just an outline but moving them all slightly in different directions?
Exactly. We're going to slightly move all of them in different directions. So we're going to say minus minus on this one, and this will probably be lower left. So let's just call it col. I don't want to do col LL because that's whack, but let's do that for now. And this will be col lower right, so this will be col, or actually let's just go LL. RL. This will be upper left. Wait, hold on. Lower left. Oh, lower. Yeah, lower right. Lower right. Upper left. Upper right. Okay. I'm a dummy. Don't worry about it. You're teaching. You're trusting this person to, you know, teach you how this shit works, but you should probably ask for your money back. Non-refundable. Sorry. And then we're just gonna want the alphas from these. To be honest with you. You want your $0 back? I'm sorry, you're not allowed to have your $0 back. Non-refundable. Yeah, sure, you can have your negative $5 back. And then we're gonna want to save all these as a result. I didn't capitalize. Plus UL plus LR plus UR. And then let's see what that looks like. I have a feeling it's gonna shader error out on me. Yeah. Probably. Undeclared outline col.a. Oh. Yeah. We probably could fix those to.
Whoa.
Yeah, so what we're doing essentially is we're like, hey, there's 4 of me. Bump it. So let's get rid of that. Yeah. Whoa. Whoa. Yeah, so now what we can do is we can do the good old float for col is equal to text 2D underscore main texture I dot UV. So we're just sampling the texture as normal. And then let's do col plus I dot results. Ah! What happened? Why
It's
do?
the opposite of an outline.
Yeah, that is though. Oh gosh, now is the winter of my discontent because I don't actually know how to do some of this. It's equal to col dot A, so that'll get that done. And result is probably gotta need to do that too. So result dot A is equal to B. Results dot A. Oh, I didn't return anything. Let's just return result for now. Yeah, that's not exactly what I expected. All right, movie magic break time. Super Saiyan shader, don't worry about it. All right, blah 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 blah. All right, did that, did that. Oh, that's how he did it. Okay, or sorry, she did it. Result, outline, color, RGB plus outline. No, wait, I did that. I did everything except for this, I think. Hold on. I was so close. Ah. Something does not seem right here. I'm not cheating. That should be something. That's something. Hey! Right there. Hey! It's an outline. I did it. Hold on. There's definitely better things I could be doing here. I.UV. I'm not changing the main UV though, am I? I.UV plus I.UV. It's weird that it's shifting I.UV up here. Because I'm not doing plus equal. Why would that change that? Whoop. And then let's say, hey, result times equal tint underscore tint. So that's gonna get us our outline color. And let me take a quick jab at figuring out why it not work the way I think it work.
Does it like, if it like looks up the pixels on left that like extend off with the edge of the texture, does it like move them out?
Yeah, it's probably because I set it to repeat, didn't it? Yeah, set it to clamp.
That's different.
Yeah, it is different. Not exactly what I expected though. Let's do it the way that that person did it. I.UV UV plus float 2 underscore size 0, and then avert your eyes. Come on, is it? What's?
You just close it right in front. Oh.
He's walking away.
Wow. Some random person, he was just reading the sign and then he came by the door.
You scared him away. Why'd you do that?
Well, Lola, you want to become a shitty programmer. Mission failed. Get it next time.
Minus.
Check out. The math is
Why is it changing the size? color.rgb is equal to col.rgb.
Better than actually creating.
Oh, that's why. There we go. Now it's acting the way I think it should be. Cool. That was weird. I had forgot to remove this, which is part of the silhouette from the previous 2-pass system. My bad. But yeah, so this is an okay way to get an outline. You'll notice it still kind of has the problems of the previous system. There are kind of outlines, and it actually has more weird problems. It doesn't have outlines in places outside of the sprite render. So if we go here, it doesn't have, you know, and it doesn't have an outline out here. Also, we can kind of blow up the sprite in a way where it's just like, hey, we can get thicker outlines, but at a certain point when the outline is off the character, it's kind of like, not sure about that. But this is not a bad way to do outlines. I actually am probably going to be more of a proponent of outlines in 2D games now purely because of this. Still think that you should ask your artist for an outline if you want an outline, or at least like a silhouette or like a nice silhouette. But if for some reason you're like, I just need to test this really fast, just need to make sure this looks okay, not a bad way to go. So let's do our final shader effect for today. Actually out of time. Please enjoy that. I made this because I needed a better sprite for the palette shader. It's gone now, don't worry about it. Let's do something with this noise texture. So we can do a lot with the noise texture. It's a very good little texture that works very nicely. And we've already seen like, hey, you know, we can modify the UVs, we can modify where things kind of are. So let's just say like noisy. Let's try and, you know, do something wild. Let's try and take our noise texture and modify our UVs by our noise texture, which should give us kind of a little trippy effect. So noise 2D is equal to, I'm seriously wondering if I have to type white every time. This kind of makes me wonder about that. And let's just, blah. ST. All right, cool.
What's ST?
Stretch and tile. So that relates to, it's not here. If we go to a, oh, we didn't, hold on. That's the wrong thing. Noisy. There we go. It's these tiling and offset. I call it stretch and tile because it's the way I remember it, but it's probably not stretch and tile, it's probably something else. So let's get rid of this tint now, we don't need it. And let's, hey, you stay dead. You stay there. Okay, cool. And let's just give it a noise texture. So if we said, you know, let's just look at what it is underneath. So let's say like, hey, this is equal to, let's just say noise texture, noise. Now let's not do any of the alpha blending stuff on it. What are we gonna get? The texture. Yeah, I mean, sure, yes. And I got this texture specifically from Substance Designer. So in Substance Designer, what it will do is for its Perlin noise, it will set the R value, so red, to be some varying amount from 0 to 1. However, it'll set G and B to 1 instead of 0. I think that's whack. I don't know why they do it that way, but big shrug, that's the way they do it. And then let's say like, hey, you know, let's just multiply this by time. Underscore time. That not good. It's on repeat too. Hold on. Give me 1 second. Is it?
More than sign time? More than one, but if it was one.
There we go. So we got it kind of moving. It's moving very poorly though. Hold on. Just move by time. Oof. That is that's choppy as heck. I'm curious as to why it's so choppy. Time.w. Whoa!
Run better out of that.
Hmm?
Run mode.
Might be better in run. Let's see.
But like,
There we go.
Oh yeah, that's so much better.
but why does it have have like W for X, Y, Z does.
Yeah, for some reason they store time as two things. They store underscore time as like a float, and then they store underscore time dot whatever as like different speeds of that. Yeah, it's like some multiple of it. So like W is the fastest, X is the slowest. I don't know why they do it that way, but yeah, it's whatever. So we've got that, and what do we have with these values? Like what specifically do we have?
X and Y.
Well, I mean, yeah, we have X and Y, but what exactly does this texture give us?
0 to 1.
Hmm?
0 to 1. Or
Yeah, 0s to 1. We have 0s to 1 that smooth. Bye. We have 0s to 1 that smoothly transition from one to the other in a random pattern. So what we can do is we can say like, well, first of all, let's set this to, let's call this noise instead. And let's just have it be a fixed. And what we can now do, and this is not going to look quite great, and hold on, let me do fixed instead of float, because, you know, why not, is equal to,
fixed and float again.
huh?
What's the difference between fixed and float again?
Oh, fixed is Unity's way of kind of aliasing whatever it needs. So if you were on mobile, you want to use halves, which are 8-bit floating point instead of 16-bit floating point, or byte. 8 byte, I think. Hold on, wait. Sorry, Tucker. A half is a 4 byte. A float is an 8 byte. Okay, I'm totally messing that up. I'm 100% messing it up. Long story short, fixed will automatically pick the one that you should use. So if you were on mobile, you'd want to use the lower accuracy one just because mobile doesn't have large accuracy numbers. But yeah, so let's do the main texture. And then instead of doing the normal UVs, let's do I.UV plus underscore, or actually we have to probably do it as a float too. Float to I dot, come on keyboard, work with me, dot X plus noise I dot UV. So that should get us a big hulking
Dot
magenta.
X or dot Y?
What does it say? Incorrect number of arguments in type constructor.
Well, you also
Dot Y, right? Or I.UV dot Y.
Oh, I'm a dummy. Yeah, I.UV.y. And also we need to get the alpha back out. So col.rgb times equal col.a. So,
Yeah.
ooh boyo. Fun.
Water.
Yeah, a little bit.
Water made of human. I like that.
Let's maybe like chill this out by a little bit. So plus noise times let's do it with like 0.1. There we go. Yeah.
Oh.
Yeah, so this is a really good effect and it's really interesting. I have to add an offset though, because otherwise the way this works is that we're essentially taking our UVs and adding them by the 0 to 1 values from the noise texture. So what we're doing is we're slightly shifting our UVs in relation to the noise. This can get you some really awesome effects. This is a more complete version that I'm about to pull up. This is from Minion Makes Art's Patreon. Really good shader person on Patreon, would suggest looking at for general code. I actually pulled a lot of this from her because I'm more of a 3D shader person. I don't really delve into 2D. I called it Super Saiyan because why not? But essentially, like, oh gosh, it's so tiny. Speed X, effect size. I maxed it out though. Brightness, opacity, brightness, effect offset, kind of speed in the Y in terms of distortion, speed in the X, and then distortion scale. So we can kind of say like, hey, you know, that's how much we want to distort by, set the color of it, although it doesn't seem like it works quite the way I think it does. Say only the aura, you know, get a very crazy looking stuff. And you can get a lot out of Perlin noise. Like I've found that some of my best effects come when I'm like doing Perlin noise stuff. And yeah, so we can pop this open. This shader code is actually Yeah, this is a much more complete looking shader. This shader code and also the stencil stuff, we can talk about that later, although I don't really know that stuff explicitly that well. So if we look at it, it's not too far off from the code I was writing. Haha, I'm patting myself on the back, please. Essentially, the big problem with this effect is that you're essentially offsetting UVs, which means that you're offsetting the actual texture by a certain amount, or sorry, the actual sprite by a certain amount in order to get the effect. So what you have to do is you kind of have to add the other way a little bit to get the offset, and then add those back in order to get it back to where it needs to be. That was something that was kind of a very simple solution to a very small problem that I had to look at this in order to understand. And usually you want to kind of say like, hey, I want a parameter so I can control my speed of time, because you know, having all of these is really handy for testing just immediately. So she's scaling the UV, so she's setting the offset and the effect size in order to make sure that when she applies the effect, it doesn't destroy her her sprite too badly, if at all. And then she's essentially moving the distortion by the scale, which is however large she wants the distortion to be, and the time. So this is getting her distortion picture or texture. And then she's taking the, what is that? Set the texture over distorted UVs. So this is her setting her main texture on top of it with the distorted UV scaling. And then she's doing alpha blending. And then she's using some preprocessors here in order to add a bit of extra features, which I would love to go into. This is for going vertically, deleting the original sprite to only have the outline, and a couple other things. And then she's returning her distortion plus her, what is that? Her distortion plus her color? C is equal to, yeah, the distortion plus the color. Or just only the distortion. So this is a more complete version of the Perlin noise shader. I would love to go into this a little bit more. However, it's 7. I'm somewhat tired. That's a lie. I'm very tired and very hungry. So I think we're going to kind of cut it here for today for the shader tutorial. Thank you all for coming out. Next week, we're going to be going over Blindfong, which is something that I'm going to have to remember. But that'll teach us a little bit more about shaders in 3D in terms of actual lighting and shading and how to do that inside of Unity. And it's a little bit more math heavy than this stuff. However, I find it really interesting. And yeah, so come out to that next week. Before we leave, does anyone have any questions? Like burning, destroying? Yes.
Why do more people come to your workshop than everyone else?
Why do you more? Officer.
Also shaders and magic.
Officer. Ex-officer in the back.
Really love workshops.
What?
I'm here for the workshop though.
Don't worry, I'm counting you in the list of people who showed up though.
I'm not here.
But yeah, spring workshops tend to be pretty light in terms of attendance because people who are, already know what they're doing tend to not show up. People who are new to the club might not know explicitly, like, hey, we do workshops, which is something that is like, that's the way it works. And also, like, shaders are magic. Shaders are an interesting concept that people want to try and learn mostly. And then they try and they're like, oh, too much auto magic nonsense, too much math, too much I don't get it. And then there's other people where it's just like, yeah, shaders are hard and you shouldn't learn them. Leave it to someone else. I'm in that camp because otherwise my job is going to get taken away from me. But I don't think shaders are necessarily hard. It's just that it's kind of a separate way of thinking about programming. It's much more math heavy and math brainy than normal programming is. However, a lot of it, once you understand the auto magic parts of it, like, hey, like, what does this value actually represent? It's not bad. And I think a lot of people want to learn shaders, so that's why the attendance is okay. Don't worry, in fall, you'll get your moment. You'll get it.
Also, I think it's because in the spring quarter we have more experienced programmers in the club, but in the fall we have more beginners.
Yeah.
I'll be basically happy with shaders once I learn how to make things flow outside of the one.
Oh, you want post-processing. So We can actually cover that. However, every way I show you is going to be not great. Post-processing effects. So like we can do it the normal way. Gosh, I hate. This is gonna take a bit. Hold on.
No, let's just do it next week. I have to go right now.
All right.
It's waiting to pick me up.
All right, get out.
Why can't shaders be written in easier to learn language like C#? No.
Because C# has memory and garbage collection, and you kind of want something that's a little bit lower level in order for to get optimized. But the question was, why can't we write shaders in a higher level language like C#? And honestly, there are things in shaders that I prefer over C#, speaking honestly. I like how it does math better. In general, I like being able to say like, hey, if I have a float 3, I know like it's gonna have an X, Y, and Z component, and I don't have to write out like transform.position.x and then be unable to set it. Like, come on, Unity, what the hell is that?
I mean, float 3 is just an array of floats.
Yeah, I know, but like it's so much less words, or it's so much less letters than vector 3. I also find that it makes a little bit more sense. Because a vector of 3 can be a vector of anything, but we're usually only dealing with floats. So I'd prefer just saying float 3.
It doesn't have to be a vector, it can just be a float array of size 3.
Yeah, but the Conan. The honest answer is I like the fact that I don't have to call in mathf. I like that I know exactly what these functions do, and I don't have to worry about their implementation on the back end because, hey, look, this is the way that step works, this is the way that so-and-so works, this is the way that that and this work. And I kind of prefer that over. But that's my preference. The honest answer is you need performance and you need a high-performant language in order to make shaders work well because they are running straight to the GPU. You also need to not have to worry about dynamic allocation. So, you know, what's a heap on a GPU? Well, it doesn't exist, I assume. So you kind of don't want to have to worry about that stuff. You want to have a subset of a language where you know you can't make any really big, stupid errors on a GPU. And this is kind of it. This and HLSL and GLSL. It actually does. We literally just change this to HLSL. And I think we change this down here to end HLSL. Yeah, it's the same. It's essentially the same. CG is NVIDIA's version of HLSL, is my understanding. They should all be interchangeable, essentially. GLSL has different syntax and different functions, but CG and HLSL are pretty much the same. Most shader languages are going to be this low-level weird languageness, where it's almost like a subset or a superset of C, minus things like print. Like you don't have a print function in shaders because, you know, what's a GPU supposed to do with print? But yeah, all shader languages are going to be this weird C-like is the general gist of it. Any more questions before I end the stream? No questions?
Actually, I'm still thinking about how the blend works.
Yeah, same.
No. Like, what is the first number and what is the and
So let's just go to the standard Sprite shader one. Okay, that's not. So let's just look at this noise one. So in blend, the first word is essentially the background that's already there.
Yes.
And this is what we're treating it at, like treating the current sprite as. Let's go to the Unity site on Unity shader blend. So there's a lot here, and speaking very honestly, I'm no expert on it. So this is the value of 1. Use this to let either the source or the destination color come through fully. So if we did blend 1-1, I think, hold on, that's not the right shader. Tutorial 2, I think I did noisy, right? Yeah, so what that's doing is that's essentially adding whatever is behind the sprite already. So if we did 3D object sphere,
Oh.
Yeah, essentially it's adding them 1 and 1 in order to get a result for transparencies. However, if we do this, it should completely, disappear.
Oh, so because the alpha here is 1, so 1 minus the alpha is 0, so the background color is not add.
Yeah.
Oh, that's right.
Bye. But yeah, no, blend modes are wild. There's some weird ass blend modes in here. This value of the stage is multiplied by frame buffer source alpha value. What is the frame buffer source alpha value?
Buffer's like the previous
All right.
stream, right?
What?
Frame buffer is like the previous stream?
I guess so. Yeah, probably.
Okay.
I assume so. But yeah. So that's it for today. Stream end. Yay. My voice hurts.